Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 3 to the power of x plus 2 to the power of x is equal to 35, and we will solve this problem for the integral value of x. So here you remember one thing is x is any integer. So the very first thing we are going to do is here first I will rewrite this term as we can write 3 to the power of x as 3 to the power of x and its whole power 3 over 3. It means that I can multiply 3 to the power of x by 3 over 3. Similarly, here we can take power 2 to the power of x is 3 over 3 and it's equals to 35. After that, I can use here the nice exponential law, and you know that if we have exponent to the exponent, so these exponents are multiplied of each other, so we can write it as 3 to the power of x over 3 and its whole cubed, plus we can write this as 2 to the power of x over 3 and its whole cube is equal to 35. After that, I will convert this exponential equation into the cubic equation, so that here I will take a is equals to 3 to the power of x over 3 and b is equal to 2 to the power of x over 3, so that this expression will become, and here I can apply the conditions on a and b. So the conditions on a and b are, first, a and b are some positive integers, because a and b both are complex numbers, and complex numbers cannot gives us the negative value, so it always gives the positive integer, so it must be positive integer. And after that I can take condition which is ab is not equal to 1, and now we proceed the further of the question. Now we put the values of a and b in this equation, and this equation will becomes a cubed plus b cubed is equals to 35. And now we will apply here the nice cubic formula, and you know about this formula. If we have a cube plus b cube, it is equals to a plus b times of a square minus ab plus b square is equals to 35. And after that, in the right hand side you can focus, here we have 35, and we will make 35, or we can make the 4 factors of 35. So these factors are 1 times of 35 is 35, as well as 35 ones are 35, and 5 sevens are 35, and 7 fives are 35. So here you have these 4 cases in which we will give 35. So now we choose some cases. So here first you focus on these 2 terms, and here you can see that a plus b is less than a square minus ab plus b square. So first you choose 2 pairs in which the first pair is less than the second pair. So here you see that 1 is less than 35, so I will choose this pair, and in this pair you have the first term is greater than second term, so I cannot choose this pair, because in the left hand side you have first pair is less than second pair. So after that, the first pair is less than second pair, so we will choose this one also, and here you have first pair is greater than second, so I cannot choose this pair. So that first I can solve the case 1, and its case 1 is that we will take a plus b is this is the case 1, a plus b is equal to 1 and a square minus ab plus b square is equals to 35. So now first I can solve these 2 system of equations. So now I can name these as equation number 1 and equation number 2. So now first I will take the square on equation number 1. So when we take square on equation number 1, it will becomes a square plus 2 times of ab plus b square is equals to 1, because here I can apply the square on both of the sides. So this will become in this form. And now we subtract the resulting term from equation number 2, and it will becomes a square minus ab plus b square is equals to 35, and we will subtract these two terms. So here these two are gone, and here you get 3 times of ab is equals to minus 34, and here you get a times of b is equals to 34 over 3. So here you remember one thing is that we need any two numbers whose give the positive integer answer, okay, because a and b are positive, so it cannot give the negative answer. So here you can see that a and b are some negative integer, so it cannot be possible. So that we will rejected this case, because here we have condition a and b are must be positive, so here it is negative, so that we will reject this case. So now we move to the case 2, and in case 2 here you have the values are 5 and 7, so that here we can put a plus b is equals to 5 and a square minus ab plus b square is equals to 7. So now we solve the case number 2 here. So here you again take square on both of the sides of this term, and here you can take this as equation number 3. So now we can open first the square of this term, so that we get here a square plus b square plus 2 times of ab is equal to the square of 5 is 25, and now we subtract this term here, so it will becomes a square plus b square minus ab is equals to 7, so that now we subtract these two terms, so these two are gone, and here you get 3 times of ab is equals to 25 minus 7 is equals to 18. So now we move this 3 to the right hand side, and it will becomes ab is equal to 3 6 the 18. So this is the equation number 4. So that here you have the equation number 1 is a plus b is equal to 1. So now we solve these two equations, okay. So so that here you can find the value of a from this term, and here you have the value of b is 1 minus a, and we will put this value in equation number 4, so that this equation number 4 will becomes a times of 1 minus a is equal to 6, and here you have a minus a square is equal to 6, and now we move these all terms from right hand side, and you get a square minus a plus 6 is equals to 0. Here we make the one mistake, because here a plus b is equal to 1, because here a plus b is equal to 5, so we can use this value here, so that this should must be a plus b is equal to 5, so that this will becomes b is equal to 5 minus a, and this is 5 minus a, and this will becomes 5a, and this is minus 5a. So that now we factorize these terms. So the factor of this equation are these one, and here we finally get a minus 2 times of a minus 3 is equal to 0. So that here we have two cases. The first case is we take a minus 2 is equal to 0, and the other case is we take a minus 3 is equal to 0. And in this case we get the value of a is 2, in this case we get the value of a is 3. So now we put the values of a and b in equation number 5, so that we get the value of b, and b is equal to 5 minus a, so that when a is equal to 2 we get b is equal to 3, and when a is equal to 3 we get b is equal to 2. So that here we have the pairs ab is equal to 2 3, and here you get the pair ab is equal to 3 2. So now we will check this pair. This pair is the correct solution of the given problem. So that in the start of the question we will take here a is equal to 3 to the power of x over 3, and we take b is equal to 2 to the power of x over 2. So in this case, when you can take here a is equal to 2, so that it will not gives the integer solution. When you have a is equal to 2 and b is equal to 3, so it cannot gives us integer solution, so that we will reject it this case. Okay, because this case cannot gives us the integer solution, so that we will reject this case and we just proceed here this case only. So that here we put a is equal to 3 and b is equal to 2 in these two equations, so that we will get here 3 is equal to 3 to the power of x over 3, and in this case we have 2 is equal to 2 to the power of x over 2. So here you compare both of the sides, and here you get 1 is equal to x over 3, and in this case you will get 1 is equal to, this is also 3, sorry, x over 3. So in both of the cases you get the value of x is 3. So this is our final answer of this question, and thank you so much for watching this video. Please subscribe my channel for more exciting videos.